Before we can fully cover the concept of deseparation, we need to understand the idea of active and inactive nodes on a path. Deseparation questions involve two variables, say x and y, and a separating set of variables z, all of which occur in a graph, usually a causal graph. Asking whether x and y are deseparated by z is the same as asking whether x and y are deseparated conditional on z. We abbreviate the question as so, where the vertical bar is to be read conditional on. The conditioning set z need not contain any variables. In those cases, we ask whether x and y are deseparated by the empty set, which we can notate either of two ways. X and y are deseparated by z just in case there are no active paths between x and y, and a path is active just in case all the nodes on the path are active. So being able to answer deseparation questions requires being able to categorize the nodes on a path as active or inactive, and that's the topic to which we now turn. Nodes on a path can be active or inactive, and this depends on A, whether the node is a collider or non-collider, and B, whether the node or any of its descendants are in the conditioning set. First, let's deal with the simple case, when the conditioning set is empty. Consider the four possible undirected paths between the pair of variables a and b that go through only one variable c. The first is a directed path from a to b, where c is a mediator. The second is also a directed path, but now from b to a, where c is a mediator. The third is an undirected path, where c is a common cause. In these three cases, the node c is a non-collider on the path, and in general, non-colliders are active relative to the empty set. So C is active in the first three paths. In contrast, the fourth path is an undirected path between A and B on which C is a collider. As all colliders are inactive relative to the empty set, C is inactive in the fourth path. Now let's consider it when the conditioning set is not empty. For example, let's make the conditioning set include the node C. When a node is in the conditioning set, its status with respect to being active or inactive flips. Non-colliders, which are active relative to the empty set, are flipped to inactive when they are in the conditioning set. So in the first three paths, conditioning on C will render the non-collider C inactive. Colliders, which are inactive relative to the empty set, are flipped to active when they are in the conditioning set. So in the fourth path between A and B, conditioning on C will activate the collider C. So far, so good. There is a slightly odd case, however, the descendants of colliders. A collider switches from inactive to active when it is in the conditioning set, and it also becomes active if any of its descendants are in the conditioning set. In this graph, for example, for the undirected path from A to C to B, if we condition on D, or E, or both D and E, the collider at C will become an active node. The same idea does not hold for ancestors of colliders, nor does it apply to conditioning on the descendants of a non-collider. Conditioning on a non-collider flips it to inactive, but conditioning on the descendant of a non-collider does nothing. Let's illustrate these concepts in a more complex causal graph. Consider whether diet and taxes are deseparated by the empty set. In the undirected path from diet to happiness, to income to taxes, conditioned on the empty set, happiness is a collider and thus an inactive node, while income is a non-collider and thus an active node. If we only include happiness in the conditioning set, happiness will turn into an active node, while income will remain as an active node. If we only include income in the conditioning set, income will flip into an inactive node, while happiness will remain as an inactive collider. And finally, if we include both happiness and income in the conditioning set, both variables flip status. Happiness, a collider, becomes active, and income, a non-collider, becomes inactive. Nodes are not inactive or active by themselves. They're only active or inactive on a path. For example, consider the node health, which is on at least two paths between diet and taxes. In path 1, health is a collider. Assuming that it is in the conditioning set, health is active on that path. on path 2, health is a non-collider, and as it is in the conditioning set, health is inactive on path 2.